All right, welcome back, everybody. We're diving back into this Fender Deluxe Reverb. In case you don't remember or didn't see the last one, we kind of left off with having replaced all the components on the power board, under the doghouse on the other side. So that's the electrolytics for the power supply as well as the resistors in there. We are converting this guy to the AB763 circuit, which meant at least one change already in that power supply, dropping one of the power resistors, let's see, this guy, to making that 10K instead of the 2.2K. Oh, sorry, it's this one that is typically in there, and that just helps lower the voltage down a little bit more between these nodes. To make it so things can break up a little bit earlier instead of staying quite so clean. And we then flipped the amp over, replaced the plate resistors here, as well as we're going to end up replacing the plate resistors for this node and this node. These are all the preamp sections outside of the phase inverter, as well as the electrolytic caps in the preamp side and the bias cap over here. That will give us all fresh electrolytic caps. We did also replace these coupling caps. There were some giant orange drop caps in there. Let's see. These guys that were drastically oversized physically. This one even more so. And again, mostly just for cosmetic purposes and to help sustain basically try to avoid an issue where they're going to vibrate loose or something because they are bigger components. Didn't quite fit in there as well as they could. We are in the new space, new workbench. I have a little quick short video showing you the new workbench. So if you're interested, take a look at that. I'm a little concerned about the lighting in this area. I'm not sure if it's going to be as good as in the other space. So let me know in the comments if you notice a difference. If you can't see things as well, I may end up having to get some kind of more powerful diffused lighting for continuing to do these videos in this new space. But we'll deal with that when we get there, I guess. Okay, so soldering iron is heated up. We're going to go ahead and keep working our way over, starting with these resistors and then the electrolytic caps. Plate resistors here, more electrolytic caps, bias, and then we'll test the amp and go from there. All right, so soldering iron has been tinned. Let's see if we can go ahead and remove some of this solder. All right, got that guy free. Yeah, let's see if we can get in there. This is a different soldering iron than I was using, so I may end up changing out the tip because I have not used this one in quite a while. We'll see how it does though. And of course, starting off in a very cramped space, because I think this is a larger tip than what I had on my other Hacko. There we go. Of course, so a larger tip for your soldering iron means things are going to heat up a lot quicker than they otherwise would. But you're also going to have a situation where it's a little bit harder to get into some spaces. So you kind of have to find the compromise in there that works well for your situation. There's one. And two. Okay. 100Ks. It's funny, this new space feels very quiet. And I'm not sure what to do about that. Let's see. It'd be nice to have some music playing in the background. However, that it's hard to do with these videos because I then either have to edit it out for the video or use non-copyrighted music, which means I then have to use music I've written and recorded or something like that. Or I guess there's probably like generic YouTube music that you can get or something like that. But yeah, let me know if you have any ideas or suggestions there, because it would be very nice to just have something playing in the background that is not going to get me dinged for a copyright issue, but will also allow having some kind of atmosphere of some sort. And just to be clear, I do like it down at this space very much. It is very nice compared to the setup I had going before, which was not bad by any means, but was definitely more of a garage space. So this is great, but it's going to take a little adjustment, a little bit of getting comfortable, especially after, I think, about 5 years, maybe a little more, down in that other workspace. And the spot I had before that, I was in for maybe close to 7 or 8 years, which that place was also great, especially since I shared it with a buddy that did guitar work. The downside of it was mostly that it was in a space that had practice spaces and was a kind of art gallery space. And so you'd get people dropping by, and it's funny to even call this a downside, but you'd get so many people dropping in to say hello and catch up, or to ask questions about getting work done, that it was really hard to get work done. So, okay. Just double check these guys. Would like to get a secondary cam here on the oscilloscope and meters at some point, just to show you guys the other perspective of what's going on. within 1%. Okay. I'm going to try this a slightly different way that I saw someone else do. Go ahead and solder this side without having to cut the legs. I'm going to bring the temp up on this guy just a little bit. Was at 660. I'm bringing it up to 700, which seems high, but okay, there we go. Yeah, this one needs a little extra help. Okay. Yeah, I saw somebody else do this way, where they basically got that first side of the resistor mounted. I don't know if I like doing that. Okay, here we go. Sure, I think I prefer doing it the way that I normally do. Let's see. Okay. Okay, and we'll get this. And then once both those joints are done, we'll go back and touch this guy up. We'll see how that is. Yeah, all right. Not too bad. Not the way I think I am going to do things moving forward, but it's another method. Okay, so let's get another one of these capacitors changed out. Yeah, let me know what you guys think. Music in the background. Pros, cons. If you are someone that also makes YouTube videos, how do you do that? If you are not, what do you like to see on your videos? Do you like silence in between? Or something going on? What I was just checking there, some of these legs, the ground or the negative legs on these capacitors go directly to the chassis, which means that we can't pull out that side of the capacitor. So I was just checking for continuity from there to ground. There's a good chance with this one, it is underneath the board soldered to the chassis, which means I'm just going to clip that side instead of directly pulling it out. Okay. Add a little solder to make the old solder happier about coming up to temp. There we go. Yeah, and then this guy will just go ahead and give it a snip if I can get in there. That was a 25 microfarad, 25 volt. We're going to put in, just as a reminder, these mod, let's see, 25 microfarad, 25 or 50 volt. And again, you can always go up on the voltage with those, but keep the actual capacitance the same. All right, that went right there. Let's go ahead and remove the solder. We're going to have some good amps coming up on the channel here. Just in the workspace right now, I have a older solid state Ampeg bass amp. Not sure, I don't remember the actual model on it. I think it's a B15, but it's one of the solid state ones. Gonna be looking at that real soon. Have a older Champ, a 60s Champ that needs a looking at. It's got dropped and is non-functional. And then at least two Ampeg V4s, which one of the best amps ever made. The Ampeg V4 from the 70s. Oh. I have two of my own to work on for that, but then a customer one as well. And it's been a while since I've done one, so I'm going to work on mine first and then work on the customer one, or at the very least do them simultaneously. All right, that should do it. Yeah, and then a few other things coming down the line. Twin reverb, silver face. Yeah, a Blues Deluxe. Okay, gonna go back to my way of doing this. Get a good estimate on the legs and then chop. Yeah, we'll see if that next SVTCL is as involved as the last one. I feel like when I was doing that set of videos before, with every troubleshooting step, there was hope in my voice that that was going to be the issue. And it just kept going until it turned into a recap. So that was a fun one, but good learning experience too. It had been quite a while since I'd worked on one of those amps, and a lot of amps in between the last time I had worked on one. So it was really comforting to go through it and see how much less intimidating it was, how much easier it was than the last time I worked on one. Oh, here we go. Get those heaters out of the way. The elevated heaters is how we refer to that style of doing the heater voltage. These wires here, because they are elevated off the board. Some people think that makes a big difference. Some people think it does not. There are a lot of amp companies that just run these straight across. They don't twist them. They instead just go junction to junction, or station to station, in the words of David Bowie. Oh, we're going to need to fix that. That is not a good mechanical connection. I will need to get more light in here because it's hard enough for me to see what's going on. There we go. Yeah, the argument for the elevated heater is that is AC on those wires, whereas basically all other points in the amp past the rectification stage are going to be DC outside of your signal. So those heaters are an opportunity for noise to be injected into your signal, because you have constantly moving current. You have either changing current or a moving coil. Across stationary current. That is when you see a change in your signal. So yeah, so the fact that these signals have. Now it's just either 12.6 or 6.3 volts. Either one's fine. And these are called heaters because they heat up nodes of the tubes, which then allow current to flow through the tubes, bring them up to operating temperatures. And that's what the glow is when you're looking at a tube, unless you're looking directly at the grid with a signal going through it, with that constant background glow. Okay. That should be good. Let's do these guys, and then we'll do these last two. Now this is for the trem circuit. Let's see if we have a 5. Because that one requires a 5. I don't have my parts bins down here yet. I don't know if I brought one of those down. So I may have to hold off on this guy. Okay. But there's another one hiding, another cap hiding here. We'll replace that as well. Let's see. Now, one of the other parts of the AB763 conversion is removing these two capacitors, these 1200 picofarad guys. It looks like those have already been removed. Those are typically across the tube sockets. Okay. But we'll worry about that when we get there. We can go ahead and take care of this other area. And you can see that I'm moving around wires a lot to get into different locations, but we want to get those back as close as possible. The lead dress in these amps, especially in these kind of areas, it's very touchy. And that what that means is that you can get oscillations that are unintended. If those are not correctly oriented with each other. And that again has to do with similar reasons to why we elevate these heaters. If you have two wires at high and low voltages that are next to each other like this, instead of crossing at 90 degrees, you can get coupling between them where basically the noise from one or some amount of signal from one crosses over to the other. So you typically want to, I'm not getting heat on that for some reason. You typically want to ensure that your signals that are at a really high voltage are crossing your lower signal wires at 90-degree angles. Which sounds easy, right? But then you end up in an area where things are very cluttered, and it can be hard enough just to keep track of which are the high and low signal wires, especially when they're all the same color. So because of that, some issues can arise. You can see like these bends are typically meant as a way to try to prohibit that. Or minimize it. Typically in engineering, it's a matter of knowing that things aren't going to be perfect. So you look at the at basically what needs to be minimized. You look at priorities in terms of which things should be taken into consideration above others. Because again, it's never going to be totally perfect. Or if it is, it'll be prohibitively expensive, right? So cost is always a consideration. Maybe time to try a new tip on this soldering iron. It's really having trouble coming up to heat, and I'm at 700 degrees Fahrenheit. May have just oxidized a bit too much since I haven't used it in quite a while. One of the tests of that is, as far as I know, if people know better than me on this, let me know, but trying to tin the iron, and if the solder doesn't stick or take a tin in, as we would say, usually means there's too much oxidation on the tip. Yeah, we might be there, man. Okay, let's let that cool down, and then we'll be back. All right. Got a new tip on the soldering iron. It's a little bit of a smaller, skinnier guy, so we'll see how it does. Oh yeah. This one is tinning up just fine. Let's see if I can get this on video without dropping any solder blobs. Okay, that's much better. Probably means it's time to order some fresh tips for my soldering irons though, because my stash is running a little bit low. Okay, and let's just confirm that's the right spot for those guys. All right, so we are going to be putting these new plate resistors between here and here and here and here. The layout shows this capacitor as being perfectly vertical there, or perpendicular to the board, which is the only reason I was doubting that. And we'll get these legs bent for these guys pretty close to each other. I probably can take that down a bit more. Let's see there. Okay. This one's really not spanning much of a distance at all. Probably can go ahead and shorten this guy up too, even though it's going a little further. All right. Oh. Getting all over the place here. Okay. So what I will do is tack in this first easy node to get to. Again, with the intention of coming back to make this a little bit cleaner. There we go. And then same deal here, we'll get this guy in place. Even if it's just to tack it in. Okay. And we'll get this guy redone. That seems good. Now we'll come back, touch up this guy. And then same over here. All right, perfect. Now, let's see. Okay, this guy is a 25-25. I was worried since this is a 550, this was something else, even though that adds up with what I've always seen there. Okay, and same deal, this guy, the center leg, or the negative leg, is almost definitely going to be the ground. So we can verify that. Yeah. Is that the case for this one too? Yeah. Okay. Okay. And again, we get to deal with the fun of this area on these amps is always very crowded. So we do our best to not scar any of the wires. Or the big giant capacitors, we can move this guy back a little bit. Oh. As I say that, I get a little bit of wire. So go ahead and wiggle that guy out. Give us a little clearance. And we've got that side out. And we can now just clip this guy. All right. Which I usually don't clip if I don't have to. Just because it then, even though that capacitor, in my opinion, is not good, it should be removed for reliability. Why make it totally inoperable by clipping the leads? Instead of preserving it just in case. Now this is a fun junction point. 1, 2, 3, 4, 5 nodes already in place. One of which we already clipped, but still gonna be a little bit of a thing. Let's see. All right. Curious if anybody else out there is working on cool projects with the holidays coming up too. I know this is a good time of year for me to catch up on work because my day job slows down. Not a ton, and not even every year, but typically there's an opportunity to take some time off, and because of that, taking time off at the day job means being able to get a little more of this kind of work done, which is good because I have a lot on my plate and on my wait list currently. Let me touch that up a little more. But yeah, I'm curious if that's the case for other people. Anybody building any pedals or working on an amp project or anything like that? Or maybe even non-music related. Okay, let's see how much we can get this other side cleaned up. It is going to end up being just a big solder blob. Probably anyways. But maybe it can be my solder blob instead. Yeah, you can see this guy's just tacked in. All right. Okay, That's good. Let's see if we can get this guy in there too. Be asking too much of a single terminal. See how that is. Maybe as good as it's going to be. All right, and we're going to eventually clean this up and replace this guy. But at this point, we're going to do the bias cap, and then might do these grid leak and screen resistors here, since I know those need to be done. And then afterwards, it will be a matter of doing cleanup, checking that the tremolo works, and seeing what else actually needs to be done. So let's go ahead and get this guy and these guys changed out. And then we'll probably go ahead and do a power up at that point and see if there's any issues before moving forward. Okay, so again, this guy's a 80 microfarad at, I think, what is it, stock? Now the AB763 says 25 microfarad at 50. And this is the bias cap, which is this guy. So in our A1172, that this is stock, it's 50 so it's 70 microfarad at 50 volts. And in here is an 80 microfarad. And it's hard to see what the actual voltage is. It might be 75 volts or something. This might be 50 microfarad at 70 volts. Oh no, let's pull it out of there. Take a look. Either way, going up to 50 microfarad at 100 volts or 100 microfarad at 100 volts is kind of the way to go with these. Between 50 and 100 microfarad, I've never noticed a difference. Now again, this leg, this time on the positive, it's going to go to ground. So we can just clip this. The bias cap is reverse biased, meaning the positive side goes to ground and the negative side goes to our ongoing signal that supplies voltage to the bias circuit. Yeah, that looks like a 80 microfarad. Let me see this. At 75 volt. Okay. And we're going to put a nice FNT in there so we have a good stable bias circuit. Oh, might be time to clean out the old solder sucker. There we go. Oh, helps if I engage the solder sucker. Man, it's really interesting. A bunch of these wires are just tacked on. They're not through the actual eyelet. Which is not the ideal way to do this. In some cases it can't really be avoided, like our giant blob there. Thought doing a little redesign of the circuit. But like here on the bias, there's really no excuse for that. Also this, yeah, I wonder if that's something somebody did when they were modifying the circuit. All right. Our positive is going to ground there. Now I think I'm going to go ahead and hit this with just the tiniest dab of silicon RTV. Okay, just going to do a tiny little dab. I always say silicone. Don't know why I do that. Alright, had to clean off the nozzle here. Actually, let's not get the first little bit. Okay. Get some of the good stuff. There we go, just a little tiny bit. And again, making sure the positive side is going to ground. There we go. That capacitor is just big enough that it's worth doing this. That might even be overkill, but why not? It's an important capacitor. I've said this in other videos, but if you're only going to change out one electrolytic cap in your amp, assuming there's not one that's already bad, the bias cap, I would argue, is the most important one to change. Because if that fails, or even wavers too much, you're looking at a failure of your power tubes. Okay. Grab a paper towel here. This is interesting getting set up in the new shop because I need to figure out where I reach for grabbing things like paper towels or solder suckers. It's always pretty similar to the last shop, but things are always just a little bit different. So it takes a little time to get everything all dialed in. Okay, there we go. Now, oh, there's one more cap here. And I believe that's 2525. Yes. Okay, so we do need to change that. This is right here, kind of hiding. This is for the reverb return circuit. And I have had issues where you can get some oscillation, if that's bad. Okay, positive goes towards the tube socket. This is almost worth flipping the chassis around the other way to get to. Yeah, there it is, this guy. Okay, I think that overall makes it a little better. All right. Then we're otherwise going to the ground of this RCA jack. Okay. Mallory 2525. Okay, let's go ahead and clean up that ground spot. Not quite. I believe I've mentioned it on this channel before, but right before I started filming, I think it was the last amp I worked on before I started filming these, had a Pro reverb, I think is what it was, which is basically like it's basically a twin that needed like a full overhaul. And man, the tremolo and reverb circuit on that thing, I like rebuilt completely and then still did not work as expected. It took, yeah, I was like at the point of one component at a time, swapping things in and out to try to find the culprit. And then it would work. And then I'd fire it up the next day or the next time, and the issue would be back. It had this feedback issue. It ended up being a culmination of a couple different things, which is why it was so problematic. One issue was the plate voltage was higher than it should have been. To the point where it was causing any extra noise in that circuit to be worse than it otherwise would have been. That's kind of sometimes just how it is. Most of the time with these amps, things work within, a certain kind of set of parameters. That are expected. And then sometimes things all just don't make sense. It's pretty rare to see one like that. The only other thing I can really think of off the top of my head that was that way, where all the voltages and everything check out, but it just doesn't behave as you would expect, was a Wurlitzer piano I rebuilt the oscillator on. And same deal, like everything checked out, basically replaced all the components, and all the voltages were exactly what it called for on the schematic. And with that, it just wouldn't oscillate for the trem circuit or vibrato. So that was a fun one. Ended up having to just kind of ignore the schematic values and play with capacitor and resistor values for the oscillator circuit until something worked. And then it sounded great. Okay. So that guy's in. Tempted to say let's fire this thing up and check some voltages, and then go ahead and change out these resistors. So let's maybe do that. Okay, so initial power up, no tubes other than the rectifier tube are in place. There is still work we need to do. We need to change out the screen and grid resistors on the power tubes. Probably need to dial in the trem circuit, and then check a few other things that were modded before for a halfway conversion of the AB763 or to the AB763 circuit that wasn't completed and was done kind of in a funky way for some of the other things that were touched by this whoever did this work before. But we're going to turn this thing on the current limiter. I'm hooked up to my dummy load, and then we're going to come up on the current limiter and just check that we have voltage at the plates as well as at the screens and at the basically have bias for our power tubes before putting any further tubes in here or continuing on with more work, just since it'll be easier to catch any issues with the power supply stuff now versus once we've monkeyed with some other stuff. So I'm going to bring these switches on. Okay, and we have power. We do not have a short circuit. We're also not drawing a ton of current, which is to be expected. I'm measuring volts DC. That's the plate of our first preamp node. Okay. Now these voltages are high because we are unloaded. They would normally be lower since we are on the current limiter, but because there are no tubes, there's nowhere for power to be drawn. Things are going to be higher than normal. Okay. And this is what we are hoping to see. Okay, so I'm measuring pins 1 and 6 of each of the preamp tubes, and then either side of the screen resistor, and then the, or I guess this would be the screen resistor. These would be the grid leak resistors to show your bias. And things look as expected. So at this point, we can power down and know that we are good to continue forward. The next step would be to plug in tubes. And to actually, well, the next step is going to be to change these screen and grid resistors that I know should be replaced. And then after that, we're going to call it here for this video. We're already at about the 1 hour mark. But the next step will be replacing these resistors, powering up on the current limiter with tubes, seeing what kind of signal we get going through it. We'll hook up to the oscilloscope and the function generator to do that, as well as taking a sound test. And then after that, cleaning pots, cleaning up other parts of the circuit, attacking the trem circuit. And then assuming everything's good, this guy will be good to go after cleaning up a couple other things. So hopefully just one more short video on this one, and then we'll have it out the door. If things get funky with the trem circuit, this will be maybe a little bit longer on the next video. Sometimes these can get, there's a few different things to try there. So we'll see how far we have to go with that. And then again, cleaning up some of this stuff that was done by somebody else. And we'll want to, if we click that standby on, So drain much quicker. That's going a little slow. We'll leave that on to drain off. We may go ahead and replace this power cable too. This one's a little janky. It's just seen some wear and tear over the years. Not really a big fan of sending somebody out into the world with that. So, got plenty of those on hand. And I've said this before on the channel, but usually somebody needs a new power cable on their amp, I just throw that in for free, just as a safety thing. I care about my customers and their safety, and want to make sure they can come back with another amp. So, okay, we're going to call it. Thanks for watching. First full video in the new shop. Let me know what you think. Is the lighting okay? Is the sound okay? This is a little weird for me getting in the groove of the new setup, so a little uncertain what may be needed to make sure things are at the same quality level or better from what I was doing before. So if you have opinions on that or anything, please do let me know. Thanks for watching. We'll see you on the next one.